In the previous video, we built the first connection via MQTT with the broker. Now we move on the pairing part with the node, also known as MQTT pairing. MQTT pairing is the process of authentication and association of a physical device, that means a node, with a user account on the platform. It is an intermediate step between manually creating a node on the platform by the admin or other user and authorizing the actual device to start sending data and be controlled remotely. I have added the logic for associating a user with a node. A node can belong to multiple users. For example, imagine a device that can provide waiter data for multiple users living in different locations. In the Livewire components create node form, I add this part and the target user IDs properties to associate a device, better to say a node with a user. For example, I will create a new node. I will say Arduino Uno R4, type Arduino, for example, firmware 6, and now I can select more users for this node. For example, I use here Flux components for this beautiful select input, and I can select multiple users. For example, I want this and this and this. I have three selected user, and now I can create the node. Node created successful. I can go now to the node view. I see here the information about the node. I see the generate UID for the node. I can copy the node, and I see the user that has this node. Each user has a secret key, and I can copy the secret key, I can copy the UID, and so on. The same I have in the edit Livewire component, edit node. For example, I want now maybe only for these two users, update node and view. Now I have only two users. As I say, for the UI elements I use Flux Pro, but if you don't have Pro, you can use the free version as well. However, I believe that some components are not available in the free version, but alternatively you can use pure HTML with some JavaScript. If you don't have Flux Pro, then you must to remove from the composer JSON and then run composer install and use the free version. And the same I have in the edit node, in the view is the same, and that's all. Now I want to demonstrate the MQTT pairing method for the nodes. Okay. For example, admin or a user create a node. I will create a new node. For example, name is living room sensor. The type is AESP32, firmware version 1.0, and I will associate this node with this user. Perfect. Now I have this node here, view. I have the UID and I have the secret key for the user. And I have the status requested because each time when I create a node, the user node mapping status is requested. Next step, I will create a command in Laravel for the pairing listener. That means a command will run and it is for the MQTT pairing. That means PHP artisan MQTT pairing listener, and I will insert command to MQTT pairing listener command. Sorry, PHP artisan make command MQTT pairing listener command. Okay, the command you find in the app in the console commands here. Here is the command. I have a signature, MQTT subscribe, a description, and here in the handle function we have the complete logic. That means we connect to the MQTT broker, HiveMQ. I subscribe to the topic node UID user on mapping. I wait for the message from device that contain a secret key, check if node exists with that UID, validate if the secret key match mapping with status requested. If match is found, update the status to confirm device is now paired. And we have some logs. We log everything, success, warnings, and error, and that's all. Now, when I want to run this command, I will write PHP artisan, and I have here this signature PHP artisan MQTT subscribe, and the command is running. Now I prepare a simple code for the Arduino Nano ESP32, and we have here the node UID from the Laravel and the secret key for the user. Okay, and it's pretty simple. Now I will upload the code to the ESP. And I see the pairing is coming. I see the mapping. And now when I go in the browser, I have here for the node I have requested. But now when I refresh the page, I have confirm. That means now my device can communicate with my platform. And this command run continuously. Later, when we reach the deployment in the production, I will show you how to make the command always run in the background and always listen. This process happens only once, then for the other communication it is no longer needed. This process, MQTT subscribe listener, is only for the MQTT pairing. But I want also to present another method. I will make a folder here in the Laravel, for example, code for devices, and I will insert here the code for the Arduino on other devices, code for devices, and I will make here markdown. For example, I will make a file. I create a file in the code for devices with the code from the ESP and some short documentation about MQTT pairing in this case. For now, this device provisioning process will remain as it is for now, because during the development phase I don't need it. For my home devices, it is sufficient to directly input the secret key and the node UID into the code, but in another video I will return to this topic. This was just a brief demonstration, so you know that I also have this on my to-do. Now I want to add a new function, and I will edit the migration for the nodes. For example, I want to see if the device is online or not. I will insert here a new column, table, I will say is Boolean, and online, and default is false. And I will insert, for example, a timestamp for the last seen at, and I will set nullable. Now I make PHP artisan migrate fresh seed, and now when I go in the database, I will refresh. I go to the nodes, and now we have last seen and online. Now I will make a new command, PHP artisan make command MQTT status tracker command, and I go in the console MQTT status, and now I write the command. It's pretty simple. Is an infinite loop to process the MQTT messages. That's mean we connect to the MQTT broker using this PHP MQTT Laravel client, subscribe to the topic, and handles incoming messages. If the message is online, it set the node as online true. If offline, it set online false. It also updates last seen at with the current timestamp, and is run in an infinite loop to keep listening for updates. That means we run this command, PHP artisan MQTT status tracker, and is running. Now the device is offline. When I go in the nodes, I see is false online. That is the last seen. I tested already, and I prepare a code for the ESP. Here is the code. I add the Wi-Fi credentials, the MQTT broker, and the node identity. I copy from the Laravel, the UID, and the secret key. And in the loop is pretty simple. I have some in the setup I have some serial monitor information. I set insecure for the certificate, I don't need it, and I send if each 60 seconds message online to the status node UID. But I will add the code in the documentation, and you find in the GitHub. It's pretty simple. Okay, now I can see here if the device is online. I will connect it. I will wait a few seconds, connect into the Wi-Fi, and I see already the device is online. When I go in the database, I see true and less in at. I put the code in the folder code for devices, and you can use it and change if how do you want. Now I want to show you other solution with MQTT set keep alive. For example, here you use a technique that send each 60 seconds, for example, message to the broker. That is like heartbeat. And other solution, we can use the set keep alive, MQTT keep alive. The keep alive mechanism in MQTT ensures the connection liveness and provides a way for the broker to detect if a client becomes unresponsive or disconnected. And this MQTT keep alive mechanism is important for connection monitoring, efficient resource utilization, detecting network failures, and so on. But it works in the same. Now the device is online. I will disconnect the device, and I will see in few seconds here offline. Now the device is offline. I will connect, and the device is online. I put the demonstration code in the folder to keep alive and send online status. And this code is only for you, for demonstration, for playing, experimenting. Later, I will build code for production, how we work with different devices and so on. Here I stop, but in the next video I will continue. In this video I did some experiments and you saw some mechanisms. I put the code in this folder, code for device, you find on GitHub. And in the next video I will go deeper into details, and I will build some special service for this task. Bye.